Hello and welcome to our Spudsmart webinar. Today we'll be looking at yield monitoring in potato production. My name is Mark Halsall. I'm the editor of Spudsmart magazine and Spudsmart.com, and today I'll be serving as your moderator. First, I'd like to thank our sponsor, Greentronics, for its support for this webinar. I'd also like to note a few housekeeping items. This webinar is being recorded and will be made available on Spudsmart.com afterwards. For audio quality purposes, all microphones have been muted with the exception of speakers. If you have a question or comment, please share them in the chat box on the bottom left side of your screen and let us know who they're directed to. Also, viewers are welcome to keep tabs on Twitter, as we'll be sending out live tweets during this webinar. Today we have two speakers to talk about yield monitoring in potato production. We're joined by Karen and Tracy Cowan, owner of AgTech GIS in Ontario. Karen launched AgTech GIS in 1995 to provide tools, information, support, and training services to the ag industry. AgTech GIS has a 20-year history of promoting geographic information systems and web-based technology products to help get quality data into the hands of decision makers. Andy Dirks is a fourth-generation potato grower in Coloma, Wisconsin. Andy and his father Steve operated Coloma Farms, a 2,700-acre potato and grain farm, and both growers are very active with the Wisconsin Potato and Vegetable Growers Association. First off, here's a quick rundown on what we'll cover during this webinar. We'll start with Karen, who will discuss some of the main features of potato yield mapping. Using map examples, she will discuss how to use data collection in a mapping program for analysis and comparison, and how to create variable management strategies from collected yield data. Andy will then talk about his experiences over the past 10 years trying to accurately measure potato yields using equipment and technology such as the Greentronics Right Yield monitoring system. So let's go ahead and get started with our first speaker, Karen Tracy Cowan. Over to you, Karen.
Okay, thank you, Mark. I'm so delighted to be able to come and talk to you today about potato yield monitoring. And I always start my data and software presentations by showing a shot of in-field equipment. It's always a little more exciting sometimes than the data and software part. But it's also to underscore the fact that equipment is very, very important. If you've got good equipment, you have a much better opportunity to collect the best data that you can. And I know that Andy is going to address all of the in-field particulars that you should be concerned with. But for me, yield monitoring is all about the map. Because the idea of precision ag is built on the precept that if we can measure and document crop and landscape differences where they happen, then we can manage these differences to our best agronomic, economic, and environmental benefit. So what we're looking at right here is a 2012 yield map, second-by-second data capture, and this was kindly and generously given to me to use by Homer Vandersag in the Alliston, Ontario area, and his daughter Karen, who extracted this from their Greentronics monitor and their AgLeader SMS software for me to use today. So as you can see, we have a lot of variability in this particular map, everything from below 250 to over 500 hundredweight per acre. And I'm sure those dark blue areas that are showing those high yields would be very encouraging to see all over the place. So sometimes we have to take our eyes away from the second-by-second data capture and look at sort of more the regionalization or regionalized view. Yield maps will not only show us the response to yield limiting factors, but they also are we can use them to verify our agronomic plan. Did we plant a different variety in this particular area of the field? What was our fertility strategy? What was our timing of our crop protection products? And all of the things that go into your production year. Unfortunately, a map can't tell you why there's a problem or a success, but it will show you where. Yield maps won't just display the location, but also the magnitude of those differences. Anything that you see with a straight line in a map, such as these blue rectangular areas, there's sort of 4 regions in this map that are a little more man-made influences here. Those are definitely something that we did on this field. And anything irregularly shaped are usually as a result of a naturally occurring phenomena. So let's go back to the raw yield map in that year. We can see some dark blue sort of strips in the field, and it underscores the fact that we really need to make sure we're using the best calibrations, we've got the right swath width entered, and all the right settings and placement on the equipment. But when we see these anomalies, we can use the map to go back and improve the equipment settings and placement. Because obviously good data starts in the field, but it's a two-way conversation. We can use the map to go back and fix things in the field. In this particular case, I've just changed the legend a little bit so you can see this. Those black areas are those runs or those passes that are a little bit excessively high, or I think we have a problem with. And the fact that in our software we can identify them and we can correct them or eliminate them, as the case may be, allows us to change that yield zone map, if you can picture it, that had those big black, or sorry, those big blue man-made features in them. We can take those out or fix them such that this is the actual, more true representation of that 2012 cropping year. So we can use tools provided in an agricultural GIS or a purpose-built software to reap best data from collected data. So to eliminate any of those errors, first we have to have a software that can do it. We have to identify them. And in fact, this particular map has 928 points of data that are bad, wrong, or maybe suspect. Now you can barely see them, and I did that on purpose. They're really not that important. But the software allows us to identify them, to clean them, or to scale it to what we know the normal to be, and to, again, use it as a diagnostic tool to go back and refine what's happening out in the field. And you'll notice, if you can see those black dots, they're usually at a stop-start position, they're at a headland, and they can be gotten rid of, and then the clean data is then stored for the future and becomes our clean data. Now this is the 2014 yield regions. So what we see from this particular year's data is the data trends as presented by the yield data. And while it's really important to know, or we all know, that a map to us is more like a picture or a visual representation, and it's very important for us to see those patterns. It helps us understand very complex spatial information. But the bigger importance is that these maps are they're an actual mathematical model. And when we define multiple types of information at the same place, we can use mathematical functions to make new maps built by calculation. So very simply put, if I take that turquoisey blue area, or all of my higher yielding area, blue area, times crop removal factor equals my nutrient crop removal. So I can use this map to calculate the phosphorus removal, potassium removal, or any other nutrient factor to help me refine the agronomic prescription next time around and to understand the interrelationships with them. We very often use these maps not just to calculate for planning purposes, but also at the end of the season. They become profit maps. So those higher yielding areas times the price you get for your crop minus your expenses is your map. We have the higher yielding areas. Obviously you think of those as our higher profit areas, but we have to look at the variable cost or the flatline cost across all of those acres as well. So these maps are not just pictures, they are calculators. Another thing we use this for is to formulate yield goals, because many of the equations or formulas that agronomists use to make recommendations are asking for a yield goal as a target, and this gives you your actual yield, more realistic yield goal, rather than a generalized county-wide type of number that you might be using at this time. And this is an awesome map for using for on-farm research, both for planning where you're going to place plots, and also this is your report card for how well did they do. Another way we express yield as percent of average. This is what you hear termed as a normalized yield map. So instead of just looking at the hundredweight per acre, the tonnage per acre, which is the actual yield, I want to know the relative yield. And so we use this normalized so that we can not only compare with other potato yield years, but also compare with other monitored crops. With normalized yield, I can compare my soybean crop or my corn crop monitored map with this, because I'm now expressing it as percent of average instead of actual. When we start getting into multiple years, which is the ideal scenario, we can start refining our zone maps so that we can maybe have a more reliable variable rate zone to start with, or a management zone to start with. And it also allows us to build libraries of good year, bad year scenarios. The neatest thing and most exciting thing about georeference data is that when we have a lot of things happening at the same place, we can start overlaying maps. And this is a very simple overlay that I have here. I'm showing you the regionalized yield map as well as the irrigation, the circumference of the maximum irrigated area in this particular field. So how many other things can we map? Do you have your as-applied spray for all the products you've put on this field? Do you have a planting map? What about tillage? Your scouting maps, obviously soil sampling and tissue sampling maps, or irrigation maps. All of these can be combined to give us better depth and a better management potential. Whenever we have GPS of any kind, and the better the GNSS system, the better the data, but we have elevation data that's being logged whether we're looking at it or not. So I took this grower's elevation data, and in AgLeader SMS Advanced, I popped up a 3D map. And this particular map, the colors aren't the yield. The red areas are sort of the top slopes, the yellow are the side slopes, and the green is the area where water and possibly nutrients would flow. So understanding the 3D look of this field, we can now overlay, this is the 2014 raw yield map over top, and the irrigation pattern. And hopefully, by being able to look at data in this way, we can start seeing the impact of the relationships that the topography has on this field. Another cool thing about looking at maps from a different perspective is that we can twist it around. All right? We're not forced to have north at the top of the page anymore. Sometimes it's as simple as a different perspective that allows us to see and question relationships from our data. I'm going to switch now. I've heard it said that a lot of guys put off getting a yield monitor because they think they can get the same kind of information from satellite imagery instead of actually measuring the crop at harvest time. And so this is a 2014 satellite image from this particular field. It was about 6 weeks after planting. And obviously, any imagery is a snapshot in time, and it can reveal very critical indicators of crop health and development. So 6 weeks in, we're seeing in the large map on the left-hand side is the satellite imagery, and this is what we call a vegetation index. The darker green is the higher vegetation, denser canopy, more chlorophyll, more leaf area, and down through the yellows to red. And it doesn't mean the red's bad, it just means it's lesser than the green areas. And while we certainly can see some areas where the crop production, or the leaf production at least, is higher, there's some resemblance to the yield map, but it's not identical. Now we'll look a month later. This is August 19th image for the same field in the same cropping year, and it's very interesting and very illuminating. But while we see some certain patterns emerging here that we may see in the ultimate yield map, it's not exactly the same as having the actual yield measurements for a final field report. These things are things that these two pieces of data should be used in combination, not in isolation. So what else can we use yield mapping for? I think it's a great planning tool. This particular map happens to be a bare ground image of that same field, pre-season, showing higher, lighter grounds, lower, more moist early season ground. And when we look at that information, we might be using that or combining that to plan out a soil sampling mission. And this is what a grid sampling, systematic sampling might look like across this landscape, trying to capture all of those different soil characteristics. But my opinion is, how much better would it be if we know that these yield maps can be our crop removal calculators? How much better would it be if we use these maps while we're planning our soil sampling missions? So it becomes a great planning tool as well. I'm going to switch gears a bit. I'm going to show you a screenshot from a program called Crop Track. And this is another aspect to yield monitoring and basically potato crop production that is very important to you, obviously. And that is the detailed type of records that you are keeping. And this just happens to be an app that goes on an iPad or an iPhone. With iCropTrack's detailed potato monitoring forms, we can capture everything throughout the season. This is not only for regulatory reasons. This might be for traceability, for efficiency, to manage personnel, equipment, resource management of all kind. It's our way of providing who did what, where, and how much. But where maps come in, it's the where component that is very important. So within CropTrack, I've also imported the yield data. It's a little bit different representation, but this is a yield map from that same field. We can now use that as a backdrop when we're collecting new data to have that historical data at hand. We use it for sensor placement, for irrigation planning, and not only the in-season, but the off-season observations that are made for this field. We obviously can link this to other resources such as weather monitoring, sensor monitoring, or in fact any connected device, which is becoming more available to us, especially in the area of irrigation. Another trend is to be able to take our maps with us, to have them on your smartphone. And this indeed is just a screenshot from my smartphone where I've taken a map from my SMS software and I've popped it up into the AgLeader Agfinity web portal, which is a private data storage area that SMS users have. And we would now be able to see this while we're planning, while we're scouting, while we're sampling, tilling, spraying, or anything else that we've got happening in that field. And this is the yield map in a different setting that we can use for maintenance or agronomy, to manage our test plots, or to troubleshoot those trouble spots. We feel that it's really important to have these mobile maps, not just paper maps, so that we can communicate within your organization, where you can communicate with your advisors and suppliers. You have a whole different conversation with your suppliers if you're both looking at the same map. So to draw this together, I'd like to offer these 8 easy yield data tips that I feel are important to consider if you're getting into improving or fine-tuning your yield monitoring activity. And one is to collect as much map-based information as is possible and practical for your operation. I also recommend you keep all your original or source data that you bring in from your machines. Computer storage is pretty cheap these days. It's easy to store it all. Keep it, because we never know what neat software or capabilities are coming down the pipe with different companies that we'll wish we had it. I then recommend you house it in a computer software so that you can view it as well as storing it for the long term. There's no point having this great data and not having an easy way of looking at it and working with it. And this is just a little snapshot of an SMS or what all programs look like, organized by year, by type of data, throughout the system. I highly recommend you think about following good data hygiene. And what I mean by that is to use the best GNS or GPS systems that are available for your task, to use recommended calibrations and setups for your particular equipment. And if your service provider has a service plan, buy it. Use their resources. They know their equipment, and they're so willing to work with you to fine-tune and improve on what you can do in the field. I advise you to keep both any in-field and in-office software or versions of the equipment in current condition. This is not a one-time purchase. This is a continuum, and things get improved and added to all the time, so you got to keep current. I recommend you back up your data to a safe or secondary location. And if you have any service providers working with you, provide a copy of the files that they're working with digitally. Don't just get a paper map. Get something that you can combine, or you have the digital information as well. Next, commit to learning new ways of using this information. If you've got it, get your hands dirty with it. Get your hands on the maps and think about new ways you could use this. Don't wait for a so-called perfect system to be complete. Every company is continually improving and developing their product, and you can enter this continuum at any time, and it's always going to be better next time, but it's never going to be done because they're going to keep improving upon it. So it's an ever-changing process, and it always has benefits to get in and get working with it. I advise you to team up with service providers or colleagues so that you can share data, learning, and insights together. Because I think grower-to-grower conversations are always valuable, as you will know from listening to Andy's experiences. Lastly, actually look at the maps and the things that you gather. Ask questions about it. Be curious and become map literate. As my opinion is, of all the georeference data that can be used as a basis for unlocking potential and improving crop production, I feel that yield data is the key. So with that, Mark, I'll hand it back to you.
So we'll proceed with Andy Dirk's presentation. If anyone has any questions for Andy afterwards, feel free to type them in the chat box and let us know who they're directed to. We'll try to make sure the presenter has a chance to answer them at the end. Over to you, Andy.
Okay, thank you. I'll give you a little bit of history about our farm. We farm 2,700 acres. About a quarter to a third of that, 750 acres, is typically in potatoes. Our normal rotation is potato, field corn, soybean, then back to potatoes. But we have some rotational opportunities here that are great from an economic and agronomic perspective. You can see some canning crops, corn silage, carrots, peppers, alfalfa, some other very specialty hand-harvested crops. Wonderful things for us from the farm perspective, not necessarily a great thing if you're trying to build yield data history. We started monitoring yield in corn and soybeans back in the mid-1990s. Shortly thereafter, we started trying to do potatoes. It's been a real challenge at times. Any of you that have tried monitoring potato yield, it's definitely not as easy as grain. We've had hardware challenges, we've had software challenges, we've had communication between the hardware and software. It's been a struggle at times training the operators. They want to be harvesting potatoes, they don't want to be messing around with computers and calibration and tearing and that sort of thing. We've really struggled on the software side of things. Getting good data in the field is a real challenge, but once you get it out of the harvester, getting it into the computer and making it useful for decision making is really difficult. We have a fantastic potato research team here in Wisconsin, but the precision ag side of it is really lacking. And so we have a ton of data of varying qualities over the years, and figuring out what to do with it is a challenge I think all of us are facing in precision ag. So here's some pictures. We have the equipment set up on two different harvesters, one self-propelled Gallenberg that you see here. Another picture of the load cells, pretty typical harvesters. Here's a pull type, double L. The current equipment is all Greentronics. We started originally with HarvestMaster. They don't really support those products anymore, so we've had to transition over. Installation is quite simple the way they're set up now. This is a broader picture of the full self-propelled harvester. And then get into some of the data. This is very early in grain harvest. One of the first years we could produce maps that I thought were quite good, and we were very happy with. And then you get into potatoes, and things like this can start to happen. Some of this spacing you see along the right-hand side of this field is from a power line running along that field. It interrupted the GPS that we had at the time. That wasn't RTK. It wasn't anything like we use now, but this again was a case where we originally had it just on one harvester, so these gaps over on the left-hand side of the field are gaps from when we had to switch to the backup harvester for a little stretch of time. Other fields, as we went along, things got pretty good. The timing is so much more challenging on potatoes. If you can see the red dots here, let's not worry about I continue to have software challenges. Maybe that is fair. My system that I've used for a long time for managing our harvest data is an old system from SST, and then when my computer finally automatically updated to Windows 10, I lost the ability to use that anymore, so I've been struggling to find data. So my legends are not exactly accurate here. But one of the biggest challenges that we find on potatoes is you see all these red dots. That's where the harvester stopped and you switch trucks. And so sorting out that data is much different than grain. In grain, typically you're running at least from one end of the field to the other end, and so you have a consistent process. Some of these bigger red dots, these are old burn piles out of this field, we think. And so we've been able to see those repeatedly over years in different crops. But the fact that you're starting and stopping, maybe you stop, maybe you run the potatoes off the boom one time, or when you get to the end of the field, you do that, really takes off that timing. It's much longer to get from where the digger bed starts all the way up around, especially on the big self-propelled harvesters with airheads. You're really just delaying that point from where you pick it up to where it goes in over the load cells. That gets to be a challenge. Obviously, digging conditions can change. This is the same picture, just the computer filling in the gaps. Again, these bigger spots you can see on the left-hand side, those are things that are real in the field, but it's not hard to get little spots in places where I think it's really just the harvester stopping in between trucks. It's not really something wrong in the field. Again, here's another field where you're seeing that. Lots of the little red dots. So you're going at, I think I got one here that shows the speed. Maybe not. But again, all these red dots are not necessarily changes. The broader ones where you see the yellow and the movement through here is good yield data. But there isn't a really simple way. You'd think you could just take out anything that's below a mile an hour or something like that, but then you end up with gaps. The cleaning of this data, and that's really what I think we want to hear from Karen, is a real challenge. If you can get the operators trained, if you can get the equipment working right consistently, which Greentronics has helped with immensely, running them through our Trimble FMX computers. The display's big, you're seeing the map all the time, so the operator can see that things are working. You're not looking at a tiny little 2x2 monochrome display while you're trying to do all these other things, watching chains and watching how much dirt you're carrying up. They're much easier to calibrate and to tear. We typically don't, we'll tear things in the morning, but we typically don't actually change the calibration settings when we're in the field. I'm really most concerned about the difference in yield in the field, not necessarily what the actual number is. We'll take some calibration weights. We try to do it once or twice a day, or maybe have one driver that will go over a scale every couple times when he comes in. And then when I go back, when that field is done with harvest, then I'll go back and see if we need to manipulate the total numbers to get an accurate number of the actual yield for the field. But really for the analysis that Karen's going to talk about, the thing we're more concerned about is the variation within the field. And so the only other step, this slide lays out the equipment that we're using currently. The next step for us, and that's the other real challenge in potatoes that you don't have in grains, is that the quality is such a huge aspect of the value you get out of a potato crop. And so one of the things that Greentronics has come up with, and I don't know that anybody else does this, is they have a system called Right Trace that will track from where the load was harvested in the field to where it will end up in the storage. And so if you are taking potatoes out of storage and you get into a spot, you can track back to where in the field that came from, find out if it is an agronomic challenge of something that happened at that spot. And we've never been able to do that before, so we're pretty excited about that opportunity.
Thank you, Andy. If you have any questions for Andy or Karen, please type them into the chat box now. Great job by both our speakers, and we'll now commence with the Q&A part of our webinar. Our first question is for Karen. A viewer asks, what resolution is that imagery used in your presentation?
Oh, good question. That particular imagery is what we call Landsat imagery, and the spatial resolution is 30 meters.
Another viewer noted that you used Ag Leader SMS Advanced. Have you looked at other programs, and does SMS do everything you want it to?
Well, that's a really good question. There's a number of products on the market, and on pretty much every one of them, any of the farm management information softwares that have a mapping component can receive potato yield monitoring data. I've chosen Ag Leader SMS because it is a very full-bodied program. It can take information from any brand of equipment, and as we've seen from a few of the example maps that I've made, all of those maps were created in SMS, both the two-dimensional and three-dimensional, and I have found it a very robust system to be working with. There's also a farm level called SMS Basic, and I noticed that Andy is using that for his on-farm data collection. So whether you're a service provider or a grower, SMS has some great tools for using for any kind of georeference data. It also can handle things like soil and imagery data, and pretty much anything that you would want to be looking at, SMS has those tools. But again, many others do in the industry, but I've just found that best of breed.
Thanks, Karen. I have a third question for you from another viewer, and that is, do you see more of a correlation between nutrient variability, landscape position, soil texture, etc.?
Well, that's a very, very large question, and I think that that's something that the entire industry and researchers are all trying to get a handle on. But I think the answer is really it depends. It depends on your particular field. And one of those or a group of those conditions maybe exert more yield-limiting factors or more correlation to how your yield performs than on other of your fields. And certainly when we're talking in Ontario versus Manitoba versus Wisconsin versus other potato growing areas, we each have some unique characteristics. Depending on where you are, some of those factors override others. All are important though, and this is why we need to collect all of those different kinds of data so that we can find out for this field what is the most important factors to crop production, and they may be slightly different than even the field across the road. So it's a good question, but it's one I don't have a really definitive answer other than collect data and examine it and ask questions, and the industry's all over those issues, and there's lots to be learned.
This is for Andy. Andy, how much issue do you have with mud?
We're really fortunate where we are. We're on very sandy soil here, so there isn't a lot of mud. Certainly, that can be one of the big challenges. If your harvest conditions are changing, on a daily basis, most of us can't get through fields of 100 to 150 acres in a day. So if you've got 2 good days and then you get a day that's had some moisture, and you have to figure out some way to compensate that. If that's having the operator estimate, what percentage of mud, of the total weight was mud. There isn't a way that I'm aware of, and maybe Karen can get at that. As far as in the yield monitoring equipment itself, I don't know if there's a way to do that. It really would be the operator recording that information and doing that in post-processing, basically. We're very fortunate, as I said here, our percentage of non-potato product moving over the harvester is certainly less than 5% in most cases, usually less than 3%. So as long as it stays consistent, it doesn't matter a whole lot. But if you get differences, that can be a challenge.
A related question would be, how do you actually measure the amount of dirt? Is it through cameras or just a visual assessment by the operator?
For us, it's generally a visual assessment by the operator. We will occasionally, when we're going into storage, we will measure the amount of any non-crop product that is taken out in the process going into storage as we grade. So we'll collect the dirt that falls through chains, that sort of thing. It goes on dump trucks, weigh those out. As far as I know, there isn't a visual assessment tool on the harvester that's available. We have a University of Wisconsin researcher that's been toying with building something like that, taking something like an automatic grader in the packing shed and putting that out on a harvester. And somebody's told me that they do that in some other countries, but I'm not familiar with that. For us, it's just a visual assessment on the operator's part.
Andy, how frequently do you calibrate your potato yield monitor?
We certainly, when we get started, we'll calibrate it as much as we can to get it right going into the season. And for us, it's a bit difficult because we'll start harvest on early potatoes maybe the 1st of August, and we'll go all the way through early October. So it's a pretty long range. As I mentioned, though, I try not to actually change the settings when I'm in a field. I've just found that that's harder to correct later, because then I have to keep a record of when I changed it, what I changed, by how much. I try to do calibration loads, a few a day, and then if we have to make some adjustments afterward, it's easier to do that. But our typical operation is tear the harvester in the morning, or tear it if you see some odd readings during the day. But we just record calibration loads, a few a day through the field, and then try to do adjustments afterward to get accurate yield numbers.
Another question for you, Andy, is how do you think the quality of your potato yield data compares to that of grain yield monitors?
I think if the digging conditions are good, I think it's better than grain yield monitors. I think because of the drum and the movement of the crops through a combine, I think you have less consistent feedback from the field to the actual where the yield monitor is measured. In our experience, if you've got the time, and again, this is very difficult for an operator to do, they can do it anecdotally, but if you're riding along on the harvester and can watch that crop come up, I mean, it's not unusual for us to see, 50 to 100% changes. So, say we're averaging 450 hundredweight in the field, we might see just in one pass with a harvester across the field, we may see yields as low as 250 bags and as high as 600, and that's not unusual. So if the conditions are good, I think the potatoes equipment does better than grain, and if everything's calibrated and working well.
I have another question or two for you.
Sure.
The listener wants to know if you have the monitor on the harvester or on the windrower as well.
We just do it on the harvester. We have a 8-row windrower that windrows into our 4-row harvester. That does present some challenges as far as getting perfectly accurate. In a perfect world, I guess if you're worried only about yield monitoring, you wouldn't use a windrower. So we have not tried, and I'm not familiar with anybody that's put a yield monitor on the windrower to try to do that, because then you'd have to take that weight off of the harvester. Again, that would maybe be something that, surprisingly, there really are not a lot of people in our area that measure the yield, and I think some of that's because it's so difficult, and maybe because people like me share how challenging it is. But I think Karen made a really great point. If you're going to wait till everything's perfect, you're never going to get data. You need to start collecting data when you can. And therefore, I'm willing to accept the fact that I'm only picking up 12 rows of data each time, and I'm not really necessarily in the center of those 12 rows. But it's still better than not having the information.
I've got one last question for you, Andy.
Sure.
Is extra fertilizer or irrigation applied to specific zones that correspond with higher yields from the harvester?
That's the theory as we get there. That's one of the challenges with us not having, we don't want to make that decision off of 1 or 2 years of yield data. And so we try to wait until we have multiple 4, 5, 6 years in multiple crops before we really start adjusting the agronomic practices, basically. Irrigation maybe is a little bit different, although that comes with a whole wealth of other challenges. You get into all the data layers that Karen talked about to do variable rate irrigation well. It's not as simple as just soil type and elevation. It's much more complicated than that. We're finding, same with placing moisture probes, incredibly important where you put it and understanding where in the field and what kind of water holding capacity that particular spot in the field has relative to the rest.
One last question. Has the yield monitor helped you decide not to grow in certain areas of the fields?
That's a pretty hard thing for us farmers to do. We hate not planting areas. We have a few areas that, yes, we've abandoned planting. It's just cheaper to leave it. It really gets down, and Karen didn't quite get to that point in her slides, but certainly if you go all the way down the road, then you can put the dollars to each of those management zones and decide, is it worth putting more money? Is it worth putting any seed in that area? I mean, that to me is the ultimate goal. It's just really challenging to get there if you don't have somebody like Karen to help you do that.
Thank you, Karen and Andy, for answering our questions today. That's all we have time for today. I want to thank both of our speakers for taking the time to share their insight and expertise, and I hope that everyone has found this information valuable. I'd also like to pass on a very big thank you to our sponsor, Greentronics, for its support. I also want to quickly thank our team working behind the scenes for their dedication to making this event happen. Thank you to Caleb McDonald, our Director of Digital Strategy, and Teresa Kurgowitz, our Marketing Design Manager. This presentation will be made available on Spudsmart.com within 48 hours. Thanks for your attention, and on behalf of the team here at Spudsmart, we hope you have a great rest of your day.